In this exercise, we will see how to analyze and design a complete RCC frame. For this example, I will give my file name as experiment number 4 frame. I will use the metric unit systems. We'll skip the job info. Let us directly go to the creating model. For this example, I am not going to explicitly give my coordinates. Instead, I am going to use the structure wizard. I will choose a frame models, and that bay frame, and I will assume there are three number of bays stories, each of 3 meters in dimension, and I will import this to my model, and I will assume square columns of dimensions 0.46 by 0.46 meters and rectangular beams of dimension 0.46 depth and 0.23 width. Now I will select beams parallel to Y and inverse the selection so that all are beams, and for columns I will choose beams parallel to Y and assign the properties. Next I will move on to supports. I will take the front view. I will select all the nodes and create a fixed support. I can directly assign it. Next I will move on to loading. I will define two load cases. The first one as a dead load and the second one as a live load. And I will also generate auto load combination as per ISO 456 table 18. These are the generated loads. In this 1.2 times dead load plus 1.2 times the live load does not make any sense, and 0.9 times dead load also does not make any sense. So let me keep it as 1.5 times the dead load and 1.5 times the dead load plus 1.5 times live load. These are the applicable load combinations. I will add those things. And now in the dead load I will add the self weight, and I have not modeled any slabs, so for that I'm going to use a floor load. Let me assume the thickness of slab and the density of concrete as 25 kilonewton per meter cube. Let me assume the floor finish contains 1.5 kilonewton per meter square load. So summing up all those will come around 5.5 kilonewton per meter square, and the maximum Y range in this case is 12 meters, X range is 12 meters, and Z range is 12 meters. If I want to force one-way distribution, I can click on this option, else I will just add it, and I will assign the self weight to all the model members. And here you can see two-way distribution, and the ground floor slabs are usually slabs resting on ground, so they don't carry any loads usually. So for that I can change my Y range. So here I have ignored the loads on the ground floor, and I have to give the wall loads on all the beams. For that I have to add member load UDL. Say for example it is 3.5 kilonewton per meters in the global Y direction. I have to assign this to wherever walls appear. For this case, let me assume the walls are in all the beams. This is hypothetical case. Selected beams, assign. So I have assumed the walls along these two level beams. And for live load, I have to assume floor load since I have not modeled any slabs. The minimum is 3 kilonewton per meter square for residential buildings as per 875. And the Y range starts from 4, X range is 12, Z range is also 12. So this is my live load minus 3, and this is supposed to be minus 5.5. Okay. Uh, Next is the analysis command. I will add a perform analysis command. I will go to design concrete as per IS 456. If you are using lateral loads, you can choose a ductile detailing. That is given by 13920/2016. So I will add command as a design beam, design column. I will also explain what is a takeoff. So design beam is supposed to be assigned to all beams in the horizontal direction. So if I assigned those things, for design column I am supposed to select all beams parallel to Y. That's it. Now I have to run my analysis and design. And it's pretty quick. Let me look at the output. Here starts the beam design. For each and every beam, the reinforcement details are given. You can also double click on an individual member to look at the results. In the post processing, you can plot bending moment diagram and shear force diagrams. For that, I will choose a particular frame. For example, this end frame. Select and choose beam cursor. I will choose all these beams and columns. Let me check in isometric view, and here let me choose selected objects only. So here I am looking at only one frame. I will change to front view, and in the beam results, let me look at the shear force diagram, and this gives my bending moment diagram. You can change the scale so that it fits better. You have a final assessment for 25 marks. Take up that quiz, and all the best in designing using STAAD.Pro.